So we're going to talk about the factor theorem, which is a kind of an explicit part of the remainder theorem. But what we're going to look at here are we're going to start by just dealing with some factors. What does it mean to be a factor? And kind of dealing with that information. So factors are numbers or quantities that when multiplied together produce a given number or expression. So the first thing we want you to do, or I want you to do, is to use multiplication to show that the factors x plus 2 and 2x minus 3 are factors of 2x squared plus x minus 6. So what that means is when I multiply, when I multiply these two expressions together, I want them to equal that other polynomial I said. So to multiply polynomials, lots of different methods. I'm going to go ahead and use distributive property. So that's going to be 2x squared. I'm going to distribute here. So that's going to be negative 3x. Distribute. So plus 4x. Distribute again. Minus 6. I've got some like terms in the middle that I can combine. So it's going to turn into 2x squared plus x minus 6, which is exactly what we wanted it to be. So that means the two factors for this particular polynomial are x plus 2 and 2x minus 3. Okay, those are the two factors. Those two things, these two quantities multiply together to get us this polynomial. All right. Now, problem number 2, use synthetic division to divide the expression for number 1 by x plus 2. All right, so if we're going to divide by x plus 2, so x plus 2 equals 0, which means x is equal to negative 2. So that's the number I'm going to use with my synthetic division. And then this polynomial expression, I just want the coefficients. So 2, 1, negative 6. So 2, 1, negative 6. All right, drop the 2. Negative 2 times 2 is negative 4. Add vertically, that's going to get me negative 3. Multiply is 6. My remainder is 0. Okay, so this is, remember, remainder constant, and then our variables were x here. So the quotient is the answer when you do a division problem. So the quotient here is going to be 2x minus 3, and the remainder is 0. Okay, so problem number 3 is the quotient from number 2. So this is my quotient. One of the factors of 2x squared plus x minus 6. And the answer is yes. So if I take a polynomial and I divide by one of its factors, what I get is another factor as long as the remainder is 0. All right. So yes. Okay. So problem number 4, a couple of parts here. Use multiplication to show that we've got two factors. Okay. So let me go ahead and multiply. Little practice here with distributive property. So 5x squared plus an x plus 15x plus 3. So I'm going to combine some like terms and then write my answer out. So 5x squared plus 16x plus 3. We were looking for 5x squared plus 16x plus 3. All right, so we're good, which means that my factors are x plus 3 and 5x plus 1. All right. So problem number 5, use synthetic division to divide the expression by x plus 3. So we're taking x plus 3, set it equal to 0, which means we want to work with x is equal to negative 3. Coefficients only, so 5, 16, and 3. Little workspace here, drop the 5. Negative 15, add vertically, there's a 1. Negative 3, remainder is 0. So if I put that in order, remainder, constant, in this case we're dealing with x. So my quotient here is 5x plus 1, remainder is 0. Okay. is the quotient from number 5 one of the factors? So 5x plus 1, 5x plus 1, absolutely yes, it is one of the factors. Okay, so summary of observation. Okay, if an expression is divided by one of its factors, then the quotient will also be a factor, and the remainder will be 0. Okay, remainder has to be 0 in order for the factor theorem to work. If it's not 0, we got some problems. All right, so problem number 8. If you divided x cubed plus x squared minus 11x plus 10 by x minus 2, what resulting information will be determined if x minus 2 is a factor of that polynomial? And remember, you've already done the division, so the remainder must be 0. All right. Again, if you do, this is that idea of the remainder theorem. So we're doing the remainder, right, the division, but in order for the factor theorem to work, the remainder has to be 0. Okay, that's the idea here. So now in problem number 9, we're actually going to do this division. So we are dividing by x minus 2. So x minus 2 equals 0, which gets me a 0 of 2. Okay, an x value of 2. Coefficients only. So 1, 1, negative 11, and 10. Drop the first one. I'm going to zoom in just a little bit. Well, apparently a lot of it. Let's try that again. All right, so 1, 2, 3. 2 times 3 is 6. That's going to be negative 5, negative 10 quotient. All right. So remainder is 0, constant. We're dealing with x's here, and then my next term up would be x squared. So my quotient is going to be x squared plus 3x minus 5. Remainder is 0. So is x minus 2 a factor of that polynomial? Yes. The remainder, whoops, let me actually put all the letters in remainder. Remainder is 0 when you divide by x minus 2. Okay, identify 2 factors of that polynomial. Well, we know the factor x minus 2. And then this quotient is another factor. So x squared plus 3x minus 5. If you want to take a quick look and double check, can this be factored further? The answer is no. I can't think of anything that's going to multiply to negative 5 and add up to 3. So just leave it as is for those 2 factors. All right, number 10 is a couple parts to it. Use division to determine if the given binomial is a factor of the polynomial. Circle the correct answer and explain. Okay, so I'm going to zoom in on part A here. I just want to focus on this, what I'm dividing by. So x plus minus 4 is equal to 0, which means x is equal to 4. All right, so 4. And I'm just pulling the coefficients, double checking to make sure as I'm going I don't need any placeholders. All right, first number drops. That's going to be 4 times 2 is 8. 13. 4 times 13 is 52. I want to double check that. It is. And then 52 plus 30, negative 37. 15. 4 times 15 is 60. Remainder is 0. All right, so that's my remainder. So is x minus 4 a factor? Yes. Explanation, the remainder is 0 after the division. Now, if you guys, apparently, I'm having issues writing tonight, but if you write decently, go ahead and write. Obviously, you know, you can put the text box up in Notability. All right, part B, same idea. All right, we've got x plus 7 here. So x plus 7 is equal to 0, which means I want to work with negative 7 in the division. Coefficients, so 3, negative 28, 29, and 140. So 3, 2, 1, none. All right, little workspace. Let's see. Negative 7 times 3 is going to be negative 21. If I add those two up, I'm going to get negative 49 times negative 7. Then be 343 plus 29. These numbers are getting really ridiculous, especially when I'm going to take that 372 times negative 7. And I'm going to get negative 2,604 plus 140. So negative 2,464. Well, that's a useful number to have. I'm doing a quick kind of double check, make sure that my math is not ridiculously wrong. And if any of you are yelling at the screen right now going, you are completely wrong, well, then we'll figure this out. This time I'm not. All right. So our remainder is negative 2,464. Now, it doesn't matter what this number is. If this number is anything other than 0, what you divided by is not a factor. All right, so explanation, the remainder is not 0. I don't know why you keep trying to put an O in 0, O at the beginning of 0. And so that's the deal. If you don't, if you do your division, you get a remainder of 0, it's a factor. If you do your division and you don't get a 0, it's not a factor. Okay, so that's the idea. All right, last problem for this video is problem number 11. It says use division to find another factor of each polynomial given a factor. So in part A, we know that x plus 4 is a factor. Okay, it even says in the answer here, x plus 4 is a factor. We're trying to figure out the other one. So let's see what we got here. X plus 4 means I'm going to do x plus 4 equal to 0. X is negative 4. So synthetic division, I'm going to use just the coefficient. So 1, negative 1, negative 20. And this is going to be a weird placeholder, but you actually need a placeholder for the constant. So make sure that's in there. So 3, 2, 1, none. I was just counting down the powers. Okay. Drop the first one. Negative 4, that's going to be negative 5. Let's see, positive 20. So that's going to be 0, 0, and 0. All right. So we already know the remainder was supposed to be 0. If it wasn't, that would be kind of weird because we were told it was a factor. So that's good. Constant is 0. This is x, and then x squared. So the other factor, and I'll use parentheses, that's the example we've got here, is going to be x squared minus 5x. All right. Now, one thing to be aware of is this is further factorable, so you may want to do that. And you could actually take this to the point where you know that it's x plus 4. This has a GCF of x, so go ahead and pop that out, and then what's left would be x minus 5. So you actually end up with 3 factors, but that's just GCF factoring like we're used to. So just a little FYI there. All right, and then part B, last problem for this one. Let's see what we got here. We know x minus 5 is a factor. So x minus 5 equals 0 gives me x is equal to 5. Little synthetic division, 1, negative 5, negative 9, and 45. So 3, 2, 1, and the constant. So that's going to be 1. 5 times 1 is 5. That's going to be 0, 0, negative 9, and 45. Whoops, negative 45. 0 there. Okay. So if I look at this, we've got our remainder, which is what it's supposed to be. Constant x squared. Okay. So if I look at this, I already knew the x minus 5 was a factor. It's listed. The other factor is going to be x squared minus 9. So this was our x squared term. Our x term doesn't exist in this problem. Constant is negative 9. Remainder obviously is 0. Now, keeping in mind what we've done before with our factors, we need to factor this further. All right, so it's going to be x minus 5. This is a difference of perfect squares. So x minus 3, x plus 3. And those are all of the factors for that problem. So if you can factor it further, take it all as far as you can when you get to the end here with this division. But you need to start with knowing what one of your factors is and then get to the rest of them. All right, that is the end of this for factor theorem for right now.